All right, today we're jumping into a real cosmic mystery. We're opening up the case file on one of the strangest and honestly most beautiful objects in our entire galaxy. It's a true detective story, complete with a stellar explosion, mind-boggling speeds, and a puzzle that's shaped of all things like a musical instrument.
So let's get right into it. What you're looking at here is called the Guitar Nebula, and it's hanging out in the constellation Cepheus. Now, this is not just some random pretty cloud of gas. Its unique shape is basically a cosmic crime scene, a puzzle that scientists have been trying to solve for decades. The big question is, what could possibly create something like this?
In any good investigation, the very first thing you've got to do is identify your prime suspect. And in this case, our culprit is a tiny but incredibly powerful object right at the very tip, or the head, of the guitar. And that culprit? It's what's called a pulsar. The specific one here is named PSR B2224+65. The best way to think of it is as the spinning corpse of a giant star that went supernova. I mean, it's only about the size of a city, but it's actually more massive than our sun. It's the spinning dynamo that's powering this whole amazing structure. But its spin? That's not even the wildest part of the story.
No, what's truly staggering is its speed. Get this pulsar is screaming through space at an unbelievable 765 kilometers per second. To put that in perspective, that's fast enough to get from New York to Los Angeles in about 5 seconds. Just wow. And it's this incredible supersonic motion that's the real key to how this whole nebula gets carved out.
It's kind of like how a speedboat plowing through water creates that V-shaped wake behind it, right? Well, the pulsar's journey through the thin gas of space does the exact same thing, creating a shockwave out in front. We call that a bow shock, and that is what we're seeing as the bright, glowing head of the Guitar Nebula. The gas gets superheated and compressed, and that makes it light up in this really distinct shape. Okay, so the bow shock totally explains the head of the guitar. That makes sense. But what about the rest of it? That intricate, looping body? For that part of the mystery, we have to look at what's happening in the pulsar's wake.
So how do you get those loops? Well, the leading theory is this really fascinating process. As the pulsar plows ahead, it leaves this trail of high-pressure particles behind it, almost like a jet engine's exhaust. But here's the thing, that jet is not stable. After a certain distance, it just breaks down, dumping all its energy out and inflating a huge bubble of hot gas. Then as the pulsar keeps moving, the whole process just repeats itself, blowing a new bubble. You do that over thousands and thousands of years, and this series of expanding bubbles could have built up the guitar's body that we see today.
But just when astronomers thought they were getting a handle on it, our cosmic detective story threw a major curveball. See, when they looked at this system with powerful X-ray telescopes, they found something else. Something that just didn't fit the picture at all. This is the second mystery, and it's a big one. It's this enormous, perfectly straight line of X-ray light that stretches away from the pulsar for trillions of kilometers. Now, if it were just a simple trail, a wake, it would stream directly behind the pulsar. But it doesn't. It's tilted at this bizarre 115-degree angle. That makes absolutely no sense. So what in the world is it?
Well, scientists came up with two main theories. Suspect number one was a ballistic jet, the idea that the pulsar itself was firing a jet of particles out at an angle. But the problem is, with the pulsar moving so fast, the pressure from the surrounding gas should bend that jet backwards, and this thing is poker straight. So that brings us to suspect number two, a much more compelling idea, that super high-energy particles are leaking out of the bow shock and then getting caught and channeled along a magnetic field line that was already there in space, kind of like beads on a string. That would perfectly explain why it's so straight.
A great theory is one thing, but you need evidence to back it up. So scientists basically went on a long-term stakeout of the guitar pulsar, acting like cosmic detectives and gathering clues for more than 2 decades. They used the Chandra X-ray Observatory, and they just watched. They took pictures for 21 years. This is such a brilliant example of how important long-term observation is in astronomy. And sure enough, they saw the filament moving across the sky. And here's the kicker. Its motion was a perfect match for the pulsars. That was the clincher. It proved the filament was physically connected to the pulsar, not just some random thing in the background. Mystery number 1 solved.
But this left them with one giant, seemingly impossible question. Okay, if the magnetic filament theory is the right one, how could you ever prove it? I mean, really, how do you measure the direction of a magnetic field on the other side of the galaxy?
The answer lies in this incredibly clever bit of cosmic forensics called starlight polarization. You see, space isn't totally empty. It's filled with these tiny little grains of dust, and these dust grains act like microscopic compass needles. They actually line up with local magnetic fields. So when light from a faraway star passes through all this aligned dust, the light itself gets a little bit polarized, and it basically encodes the direction of that magnetic field. It's an amazing trick.
So, the astronomers went and measured the polarization of hundreds of stars in the background of the Guitar Nebula. By mapping all those measurements, they could build a 3D model of the magnetic field in that region of space. And here it is, the smoking gun. At just the right distance, right where they think the pulsar is, the direction of the interstellar magnetic field they measured was a near-perfect match for the angle of that X-ray filament. I mean, what a discovery! That was the key piece of evidence they needed.
So, after decades of patient observation and some really clever analysis, what have we learned? Let's review the case file one last time and deliver the verdict. Well, the verdict for now anyway.
Let's piece it all together. The evidence gives us this awesome two-part creation story. First, the pulsar's incredible speed creates that bow shock head. Second, instabilities in its wake are blowing a series of bubbles that form the body. And that super mysterious X-ray feature? It's not a jet from the pulsar itself. Instead, it's a beautiful demonstration of particles just surfing along the invisible magnetic highways of our galaxy.
You know, the case of the Guitar Pulsar is such a great reminder that even the most bizarre-looking things out there in the cosmos can be understood if we just keep following the evidence. It shows us that the universe is just filled with this incredible physics, creating structures of stunning complexity and beauty. And it really makes you wonder, if one dead star can do all this, what other cosmic symphonies are just waiting out there for us to find them?